All right, folks, it is Friday, January 16th, 2026, and we are in the midst of what is shaping up to be a very snowy and very cold stretch of weather across the eastern United States. We have multiple opportunities for accumulating snow over the next couple of weeks, and while there is still significant uncertainty with some of these systems, the overall pattern is locked in and it favors winter weather in a big way. We need to address the potential storm system coming this weekend, break down the latest model trends, talk about the Arctic air that is about to get even more intense, and look ahead at what late January has in store. There is a lot to cover, so let me walk you through exactly what we are seeing. First, let me address something important about this weekend's storm because the models have been all over the place, and I want to be completely transparent about where confidence stands right now. Yesterday, we had some very aggressive model runs showing a major East Coast snowstorm with accumulating snow reaching deep into the deep south and then a full-blown nor'easter hammering the I-95 corridor. Over the past 24 hours, the models have taken a step back on the northern half of that storm. The southern half remains the more confident portion of this system, which is actually pretty remarkable when you think about how these storms typically play out. By the way, if you'd like specific weather forecasts for your region or city, please leave them in the comments. I'll answer them individually as time allows. Also, if you like the video and subscribe to my channel, you'd be very grateful. Now, let's move on. It is honestly pretty wild that we are sitting here on Friday and there is still so much uncertainty for a storm that arrives Sunday. But that is the reality of what we are dealing with. And I want to give you the honest picture rather than overhype something that may not verify. Let me break down what the different models are showing because the spread is significant. The European model, which is statistically the best model in the world for this type of forecasting, has been the least aggressive with this system. The most recent run shows the storm tracking too far offshore to bring significant snow to the mid-Atlantic and Northeast. It does show some light snow for the Carolinas and Virginia, but nothing like what we were seeing in earlier runs. The precipitation just does not make it far enough west to impact the major population centers. The GFS model remains more bullish on this system. It still shows snow reaching into the Florida Panhandle, Georgia, South Carolina, North Carolina, and Virginia. However, even the GFS has backed off from the blockbuster scenario it was showing yesterday, where it had a powerful low in the 960s to 970s millibar range, creating blizzard conditions up the coast. The latest runs show an Arctic front forcing the low further offshore as it tracks northward, which limits the impacts for the mid-Atlantic and Northeast. Now here's where things get interesting. We are at a point where our shorter range, higher resolution models are coming into play. The NAM 12-kilometer model, which is one of the first short-range models to cover this time frame, is actually showing a solution that is further west with the snowfield than either the European or GFS. This would be better news for the mid-Atlantic and Northeast. However, I want to be careful here because when you have conflicting signals between the major global models and the regional models, you really want to see consensus before gaining confidence. We do not have that consensus right now. The Canadian regional model shows yet another solution, with the storm tracking much further inland and bringing heavy snow to the mid-Atlantic and Northeast while keeping the Carolinas and Georgia as mostly rain. This is essentially the opposite of what most other guidance is showing. So what does all of this mean? Where should confidence actually be highest? Based on the ensemble guidance, which averages multiple model runs together to identify the most likely outcomes, the area with the best chance of accumulating snow from this system is actually the Southeast. Specifically, northern South Carolina, central and eastern North Carolina, and eastern Virginia have the strongest ensemble support for accumulation. Both the GFS and European ensemble suites agree that at least an inch or two is quite likely in this corridor. I know that seems counterintuitive. When we talk about East Coast snowstorms, we usually think about Boston, New York, Philadelphia, and Washington getting hammered. But with this particular system, the southern areas actually have higher confidence than the traditional snow cities further north. The mid-Atlantic and Northeast are not completely out of the picture, but the chance is lower than it was 24 hours ago. For the Southeast, here is what I think we are looking at. The best chances appear to be for areas from Columbia, South Carolina, through Raleigh, North Carolina, and up into Norfolk and Virginia Beach. Accumulations in this zone could reach 1 to 3 inches, possibly a bit more in favored locations if the system trends even slightly more favorable. Atlanta, Augusta, and the upstate of South Carolina are on the edge and could see accumulating snow if the storm tracks further west than currently shown. Even the Florida Panhandle and southern Georgia have appeared on some model runs with light accumulation, though confidence there is lower. For the Mid-Atlantic, including Washington, D.C., Baltimore, and Philadelphia, we are in a wait-and-see mode. The ensemble support is weaker than for areas further south, but the chance is not zero. If the shorter-range models like the NAM are onto something that the global models are missing, this region could still see accumulating snow, but I would not bet heavily on it at this point based on the most recent trends. For the Northeast, including New York City, Boston, Hartford, and Providence, confidence is even lower for significant accumulation from this particular system. The storm would need to track considerably further west than current consensus shows. That said, even the most underwhelming model solutions still show a very snowy pattern overall for the Northeast over the next 2 weeks from other systems. Looking at the pattern for late January, the signals are remarkably consistent across model guidance for an active storm track. The overall setup shows a ridge in the west, which keeps the western United States and western Canada mild, while a persistent trough in the east maintains the cold and brings multiple storm systems through. Around January 22nd through 24th, we are tracking signals for another winter storm. This one looks to take more of a southern slider track initially before potentially turning more nor'easter-like as it approaches the coast. Tennessee, Kentucky, North Carolina, Virginia, West Virginia, Pennsylvania, and Maryland are all areas to watch with this system. Confidence at this range is in the 60 to 70% range that we will have a storm, with the details on exact track and snow amounts still to be worked out. Around January 25th through 26th, there are signals for yet another system moving through the Mid-Atlantic and Northeast. The pattern supports winter storm development every 48 to 72 hours during this period, which means multiple opportunities even if any individual system underperforms. Around January 27th through 30th, we could see even more significant systems as the polar jet from the north and the subtropical jet from the south phase together. When you get that combination, it creates the potential for major winter storms. The Northeast and I-95 corridor appear to be ground zero for this active pattern, though the Ohio Valley, Mid-Atlantic, and Midwest will also see impacts. The cold air during this late January period could actually intensify rather than moderate. The European model shows the Arctic blast around the 27th potentially being even more dramatic than what we experience early next week. We are talking about temperatures possibly running 25 to 30 degrees below normal across portions of the Midwest and Northeast. In areas where you normally see highs in the 30s, you could be looking at high temperatures struggling to reach the teens. This would be genuinely dangerous cold that demands preparation. Let me give you the regional breakdown for what I expect over the next 2 weeks, based on the overall pattern signals. For the northern plains, including Minneapolis, Fargo, Sioux Falls, and Bismarck, this is going to be a brutally cold stretch with multiple rounds of snow. Wind chills will frequently drop to 20 to 30 below zero or colder. Snow accumulations will add up from clipper systems, and the persistent cold will prevent any melting. This region is looking at well above normal snowfall through the end of January. For the upper Midwest and Great Lakes, including Chicago, Milwaukee, Detroit, Cleveland, and Indianapolis, lake effect snow is going to be running almost continuously when the wind direction is favorable. Additionally, clipper systems will bring periodic accumulating snow to the entire region. The cold will be persistent, with only brief moderations before the next Arctic surge arrives. Total snowfall over the next 2 weeks could easily reach a foot or more for many locations, with lake effect zones seeing considerably higher amounts. For the Ohio Valley, including Pittsburgh, Columbus, Cincinnati, and Louisville, multiple snow chances exist over the next 2 weeks. The pattern supports both clipper systems tracking through and potential southern slider storms that could bring more significant accumulation. Cold air will be firmly established, meaning any precipitation that falls will be snow. This region is in a favorable position for an active and snowy second half of January. For the Mid-Atlantic, including Washington, D.C., Baltimore, Philadelphia, and Richmond, the weekend system brings uncertainty, but the overall pattern strongly supports multiple snow chances through late January. Even if this particular storm disappoints, the setups around the 24th through 26th and again around the 27th through 30th look promising. The cold air will be in place to support snow with any system that comes through. This region should see above normal snowfall by the time January ends. For the Northeast, including New York City, Boston, Hartford, Providence, and Portland, the pattern is extremely favorable for winter weather, even if this weekend system tracks too far offshore. Both the European and GFS models show massive snowfall accumulations for the Northeast over the next 2 weeks from the combination of all systems, with totals potentially reaching a foot or more across much of the region. The late January setups around the 24th through 26th and 27th through 30th could bring significant nor'easter-type storms. Lake effect and lake-enhanced snow will add to totals for areas near the Great Lakes. For the Southeast, including Charlotte, Raleigh, Atlanta, and Columbia, this weekend actually represents your best near-term chance for accumulating snow. Northern South Carolina, Central and Eastern North Carolina, and Eastern Virginia have the highest confidence for this system based on ensemble support. 1 to 3 inches is possible for favored locations. Additional chances may exist in late January if southern slider systems develop as the models suggest. The cold air penetrating into the region over the next 2 weeks means that any precipitation events could involve wintry weather even in areas that rarely see snow. The bottom line is this: winter is here in a big way, and it is not going anywhere for the rest of January. The weekend storm has uncertainty, particularly for the Mid-Atlantic and Northeast, but the Southeast actually has decent chances for accumulating snow. More importantly, the overall pattern supports multiple winter storm opportunities and persistent cold through the end of the month. We are going to see significant snowfall accumulations across a huge portion of the eastern United States by the time January wraps up. Stay warm, stay safe, and stay tuned for updates as these systems develop.